Okay, I think we should have some people coming in from LinkedIn and YouTube as well. Mhm. All right. Okay. Pressure into cloud. Oh, okay. Want to learn more about security. Okay, cool. So it seems like there's a good mix of people who are interested in security and AI stuff. It seems like it's 9:02. I think we can just go ahead and get started with everything. Okay. So thank you all for joining us today. I'm Jazz Koo, a solution architect at PuppyGraph, and I will be your host and one of the speakers for today for this webinar, Ask Your Cloud Anything, AI Security Insights with GraphRAG. It seems there is a good mix of cybersecurity people and people who are just interested in building an AI chatbot. So whichever camp you're in, you've come to the right place. Thank you for joining. Very excited you could make it. Today, I'm joined by the wonderful Syed from AWS, who has made a really nice AI chatbot demo for us that you'll be seeing later on in the webinar. And he's very nicely given us some resources. So we have QR codes at the end that you can scan and just play around with it yourself. If so, I think before we begin, I will just give a big overview of what this talk is about and clear up an elephant in the room. Unfortunately, your cloud does not have a mouth and cannot speak. So what do we mean, ask your cloud anything if it can't respond? Like, how are we going to get the response? Unsurprisingly, we're going to use AI. It's in the name of the title. But the most important thing that we'll be driving at is how exactly you ensure that you get reliable insights from your AI chatbot, right? So that will be the main focus of today's webinar. And just before we go into anything else, we're just going to do a little bit of housekeeping. So we want this to be as interactive for you guys as possible. This is not a classroom. Feel free to ask your questions in the chat at any time during the webinar using the Q&A feature, and we will have someone on the lookout to make sure that your questions are getting read. What the buzz is all about. Don't forget to follow PuppyGraph and AWS on X or Twitter and LinkedIn if um, and you can post, oh, sorry, and you can post following the webinar using the hashtag PuppyGraph and AWS to join today's discussion with fellow attendees so you can continue to interact even after this webinar is over. And the fun doesn't stop here. Today's session is recorded and you'll receive a recording in your email following the webinar, as well as a copy of the presentation. So if you had a lot of fun and want to revisit, or if you want to make your coworkers watch it with you, that would be great. Have at it. You'll have everything that you need. And then we can go into the speakers. I've already introduced myself. I'm Jas Koo, a solution architect at PuppyGraph, and I have two other wonderful speakers here with me today. So I will have Syed introduce himself first.
Hey everyone, I'm Syed Mahdi. I'm a partner solutions architect here at AWS. I mainly work with AWS partners to help deliver capabilities for our customers, and I've been working with PuppyGraph for the past few months now, and they've been really great. And really happy to talk about how we can use GraphRAG with some of our AWS services with PuppyGraph.
And then Waymo,
Uh,
if you could introduce yourself.
Hi, this is Waymo. Sounds like the self-driving. And, I'm the CEO and the co-founder of PuppyGraph. Yeah, welcome.
Okay, yeah. So I think then I will start. Oh, wow. Someone recognizes you, Waymo. Let's go. Okay. Um, Sorry, Jenny, can you do me a favor and help me pull up the poll? I can't see it on my screen. I just wanted to ask you guys like a quick question. How many of you have used ChatGPT before or Claude or I think Gemini, Google Gemini? If there are any others, I'm not too sure. I feel like there's a lot of chatbots out there. So I'll give you guys a few seconds to just put in your responses. Okay, I'm not surprised. It seems like, okay, ChatGPT is definitely winning out. Okay, right. So I think, oh, okay, one person said others. Interesting. I wonder what that one is. Okay, so I think I have, I think I don't have to tell you guys why text to insight is so great. It seems like you're already familiar with, um, you know, the thrill of shoving in a multi-page PDF into your chat and getting back a really nice, tidy little summary. And because it's such a powerful capability to have, it's really unsurprising that every company wants to have one that's trained on their own data because every team wants to ask their data questions in plain English. Unless you live, breathe, and eat SQL, when you need the data, the first thing you're gonna ask isn't, oh my gosh, how do I write 50 table joins? I'm so excited. No, the first thing you're gonna ask is in plain English because you think in natural language. And so that's a way more intuitive way to ask your questions. The big problem is that few of these AI, enterprise AI tools actually make it past the demo. So they're really great for summarizing like what's right in front of you, for example, your logs and your alerts, but they start to crumble when you need to ask the harder questions. And by harder questions, I'm saying harder to navigate through your data. It's not necessarily a hard question to ask. For example, who can access what, right? It feels like a point A to point B kind of question. But when you look at the actual structure of your data, you'll kind of realize that, hey, it spans across internet gateways, timestamps, different EC2 instances. It gets really complicated. And so you're going to have to prompt your LLM in steps. And maybe you spend 30 minutes trying to guide it through just to get the right data. And at that point, you're like, it's easier to just do it myself at this point, right? And what a lot of people have come to realize is that the hard part isn't the AI, right? Your model quality can only be so good if it's not connected to the data that's underneath. It doesn't have the right context to fetch you the information that you need. And so that's when teams kind of take it one step down and they'll start to think, okay, how about text-to-SQL, right? If the LLM needs the right data to get the right insights, I just need to have it generate the right SQL first, and then I can have more fine-grained control over what kind of data it's fetching. But I still don't want the hassle of having to write table joins and everything. So let's make the AI write the SQL for us. The big problem is that, SQL is still hard to write. It's the same problem. You've just brought it to a different layer because LLMs struggle with writing SQL too. And the biggest thing is because data isn't flat. Like I said, let's say I ask which users have access to this particular resource. It's going to span across different users, different assets, and different times. And it gets very hard to keep track of everything. And just like how people have limited attention spans, LLMs also have limited context windows. So throwing your thousands of tables at it to hopefully give it an understanding of what your data looks like isn't going to work out. Another big thing is that I think actually well, we hope that the data is well formatted, but over time, configurations change and maybe your tables aren't named as well as they should be. And this ambiguity is a big problem for LLMs. I'll give you an example. There's the Okta admin roles versus the AWS IAM roles. And technically, both of them could be put in a roles table, but they're different things, right? Okta admin roles kind of look at the organization's assets versus AWS IAM roles are specifically for AWS resources. So how the pipeline usually works is that you would have the Okta admin role that assigns AWS IAM roles, and then you can access the resources. For LLMs, if you ask the question of, okay, which users can access my AWS resources, it might grab the Okta admin roles and then try to connect the two together, but you're missing that intermediate step. So it's going to return you, hey, you have this really sensitive database. No one can access it. Don't worry, right? Which could be dangerous because you might have an IAM role that can actually access your sensitive database that you're not covering because the LLM told you the wrong thing. So if you think about it, one of the better outcomes is it actually writes a SQL query that fails. And the worst case, it gives you the wrong answer that sends you down rabbit holes that don't even exist, right? And so a lot of this is because it doesn't have the context, it doesn't have the proper understanding of your data. And so the fix then, what a lot of companies are doing is introducing an ontology graph for better quality SQL generation. And so it's relationship first, meaning that how all your tables connect are made explicit, and it provides a semantic layer that enforces context. So if you have like 5 different AI chatbots, they're all going to have the same understanding of your data because they all have access to this one single source of truth. So now that we've mapped everything out as a graph, why will we translate it back to SQL with text-to-SQL? So let's think about how we got here in the first place, right? So we write big joins in SQL, but it's a pain to write, to think about how to join everything together. Most importantly, it's a pain to debug. So that's great. Let's not deal with that. Let's have the AI write the big joins for us. But the AI doesn't have to write context, so we added a graph layer for that context. And then we go back to generating the SQL, even though SQL is a lot better for querying tables rather than relationships. And at some point, you have to ask yourself, why are we still querying it like we have a table? Why not just query the graph directly? And I'll show you why this is I'll show you why it's so important with a sample prompt. So over here, we have this question: find roles that have been granted excessive access permissions alongside their associated virtual machines. And why this is a very important question to ask is that when you have developers developing, they don't really care about permissions. They just say, I need everything, right? I just need to get it to work. And so it can be really dangerous because if someone can get access to their credentials, they can spin up their own VMs and suddenly they have free reign access to everything that your company's assets, right? And so with the Cypher query, Cypher is actually a graph language. And so it's kind of designed for traversing these relationships. And you see that the structure of it mirrors a lot better, mirrors the question a lot better. And it's also like a short 4 to 5 line query, in contrast to the SQL that's trying to mimic these relationships that already exist in your data. For example, the role resource access table it only exists just to mimic the allows access to relationship. And as a general rule of thumb, when you're dealing with token generation, it's a matter of probability, right? More tokens generated equals to higher chance for failure. Um, so now that we see, maybe text-to-Cypher is a more intuitive way of asking our graph questions. Yeah, expensive indeed. Um, I think token costs have gone down, but like when you're generating at such a scale, yeah, the cost can add up pretty quickly. Okay, yeah, sorry. So text-to-Cypher, maybe we can consider exploring our graph by querying in Cypher instead. And so the thing is that now we found a way to introduce context into our text-to-Cypher generation, but we had the previous problem of a lot of these AI chatbots having problems understanding context as well. And so the reason why a lot of these enterprise AI tools are failing is because a lot of companies are still trying to use retrieval augmented generation, right? And how RAG works is that you most often have a vector database and they have all their embeddings. You can calculate how similar the words are. And so they're going to do a semantic search to find kind of the documents that are most similar to your question. But similarity doesn't equal to relevance, right? And so it functions a lot more like a search engine. So you can ask it, find mentions of port 22, and it's going to show you all the maybe the top 10 documents that mention port 22. But when you add text-to-Cypher, suddenly you can start questioning about relationships, right? It becomes GraphRAG, and you have a reasoning engine instead of a search engine. Because when you ask it a question, it can now pull out the relevant subgraph that you care about alongside the entities, relationships, and timestamps. And so suddenly the context window is filled with who and where and how they all connect together. And this lets you change the way you ask your questions. So you go from find mentions of port 22 to show EC2 instances exposed to port 22 because it knows how everything connects together. And this is great because port 22 SSH port, it's dangerous, people can access it. Maybe I should focus more on these EC2 instances that are exposed. So RAG finds the correct words, but GraphRAG is really what helps you understand the connections. And why exactly is GraphRAG so important? It matters because in cybersecurity, most of the questions you ask aren't about the text themselves. They're about the context. So which services depend on this compromised host? And if this rule is breached, what's the blast radius? You have 50,000 alerts pinging at a given moment. Super busy, you have to know where to focus your energy. What attack paths exist and how do we stop it from existing, right? And so it's at this point that we want to turn the chatbot into an analyst. So we as people can focus on what we want to do, and that is remediating these problems so we can improve the company's security posture. Right. And so now instead of just retrieving words on paper, your chatbot can start tracing dependencies, rank paths by risks, and show likely impact. And all of this helps you prioritize and understand what to focus on. But if GraphRAG is so powerful, why are companies still trying to use RAG? And the biggest thing is that technically the only difference on paper between RAG and GraphRAG is that GraphRAG has a knowledge graph that provides a unified view of all of your data. But in actuality, most GraphRAG setups still rely on loading all the data into a separate graph database to make this graph. And this means you get costly ETL pipelines and a separate graph database that you have to maintain. And graph databases don't scale with the data lake size, right? Because you have such interconnected data, you have to think to yourself, how am I logically splitting this graph up? And it's a really hard question to ask. But the big thing is that when you're dealing with security data, it's coming in such such high velocity and such large volumes that you really do need that scale. It can be a big deal breaker. And you're dealing with sensitive security data, so it introduces new governance headaches. You have another asset to take care of that might introduce new vulnerabilities. And also, if real-time graph analytics is your goal, graph databases might actively impede that because you have to watch your data crawl slowly through the pipelines to finally land in your database. And that's also another reason why we've chosen AWS S3 tables for this demo, because it's, first of all, a lot more affordable to store your data in a data lake. And second of all, because it's columnar storage format, it's kind of built for these intensive OLAP transactions versus there's a lot of the graph database are more OLTP, right? So they're not really built for this scale and complexity of questioning. And so another big gain that you get out of it is that you get to separate your storage from compute. So AWS S3 tables will handle all the storage for you. You just have to find a way to bring graph analytics to your tables. And I wonder what that could be, right? Wouldn't it be great if there's a better way to query your lake as a graph? And that's where PuppyGraph comes in. So with PuppyGraph, you get to run your Cypher queries directly on your AWS S3 tables. And a good thing about that is because your data still lives in your S3 tables, you can run the same SQL queries that you've been running this entire time, right? The big thing is that you get to skip the ETL and data duplication. And in the later demo, we'll be using Strands and Bedrock to translate the questions to Cypher. So you still have that context enriched LLM. And you get to see your live relationships across billions of records because we're connecting directly to your data source. So you get to see the information update as it streams in. So we go from copying your data into a graph database to connecting directly to your data sources, which is a big win. So at the end of the day, we started from, yes, bypass ETL. Oh my gosh, data migrations, so fun, isn't that crazy? Yeah, we'll be giving recordings after. So you see the evolution, right? We started from, okay, enterprise AI solutions aren't that great. But we've seen that it is possible to get an AI chatbot that works. So why would you settle for less? When you introduce text-to-cipher capabilities for your product, you unlock context-aware alerting and multi-hop attack path reasoning, right? For example, lateral attack paths are really hard for a lot of these cybersecurity tools to trace. But when you have graph analysis, it's very easy to see like, hey, maybe this path is different from what the user usually takes, and it'll flag it out as suspicious behavior. You get root cause analysis powered by graph traversal, so you really get to narrow your focus into what matters. And so the biggest thing is that when your data layer becomes your reasoning layer, suddenly your LLM is able to give you a lot better insights because it's able to ask better questions of your data. And so now that's kind of, I'll pass it off to Syed to go into a bit more details of how exactly he set everything up with the architecture. So I'll stop sharing my screen, and Syed, if you want to take over.
Sure thing. All right, can everyone see my screen? Looks like yes. Okay, perfect. So thanks, Jazz, for that great presentation. I just want to go over some of the AWS services that we're using in today's demo to create this AI GraphRAG enabled chatbot that interacts with our data that's stored in or used by PuppyGraph. So first, one thing I want to point out is PuppyGraph is being run on an EC2 instance here in our AWS account. So it's running on this EC2 instance, and it's connected to our S3 table bucket, which is storing our data sample that we actually have linked in PuppyGraph's GitHub at the end of this presentation. So if you want to take a look at that data sample and see how it's set up, it's all going to be there at the end of this presentation for your reference. In this S3 table bucket, we have our data sample. PuppyGraph is now creating a graph representation of that data. And from there, we have our Lambda function, which is going to be interacting with this data using our Amazon Bedrock agent. So recently, Amazon announced and released our Strands framework, which is open source, and it's really easy to use. You can create an Amazon Bedrock agent that takes advantage of our various models. We have Anthropic, we have our own Amazon models, we have DeepSeek models, all available through one API on our Amazon Bedrock service. So from here, we also have our Amazon OpenSearch service, which is being utilized by Bedrock as well as a knowledge base. With our S3 bucket that's connected to our OpenSearch service, you can store structured data or unstructured data, and OpenSearch is going to index this and store it in vector DBs, which our Bedrock agent and our Lambda function is going to be able to take a look at and use that for context when it's constructing our Cypher queries, when it's constructing our AI responses as well. And so the main big service that we're using in today's architecture is Amazon Bedrock. It's using that LLM to generate these responses, generate our Cypher queries, which we'll also be talking about in our presentation later. And it's taking these data query results from PuppyGraph and generating that response to the user after they input their natural language query. We also have our application layer here with AWS Amplify and Amazon API Gateway. API Gateway is going to be our front door to our web application, where we're storing our web AI chatbot and deploying that to the web using AWS Amplify. So big key things to note here is that this is a rough architecture for a simple demo to use an AI chatbot with PuppyGraph. You can definitely extend this and work on it to make it more highly scalable, highly available, and make it better for sure. But this is the least amount of services you can use with AWS to deliver an AI chatbot with GraphRAG using PuppyGraph. And on our next slide, we'll talk about our data sample set that, again, is on PuppyGraph's GitHub. So if you want to take a look at this, you can at the end of this presentation. So this is a cybersecurity dataset sample. It contains a network infrastructure that PuppyGraph is going to be representing as a graph. And so users can use this data to identify potential security risks, such as public IP addresses being exposed to the internet, network interfaces that aren't protected by any security group, roles granted excessive access permissions, or security groups with overly permissive ingress rules. So this is really useful for cybersecurity teams who have their cybersecurity data stored in Apache Iceberg tables and their S3 table buckets. They can use PuppyGraph to query that data as a graph. And users can ask our AI chatbot about this data and get results really quickly with context-aware responses from our AI chatbot. So one main functionality of this demo that we've implemented is Text-to-Cypher translation. So it's going to be taking those user inputs into our chatbot. An example on the left of this slide is find network interfaces that aren't protected by any security group, along with their associated virtual machine instances as well. And first, our agent is going to take this. It's going to send that over to a Lambda function. It's going to process it and have the Bedrock agent use the LLM to generate a Cypher output for this user input. And on the right of the slide, you can see what that Cypher output is going to look like. From here, we're going to take that Cypher query. Our Bedrock agent makes sure that this is a valid Cypher query before it sends it over to the PuppyGraph query engine. And from there, PuppyGraph is going to use this query to get results from our data graph. And on the right, you can see a sample of what this would look like for those results. From these results, we're going to go ahead and send that result back to our Bedrock agent again to generate response using our OpenSearch service as well for context to generate that response to our user. And so on the right, on the left, I mean, you can see the result sample again. And on the right, you can see a little bit of what that response would look like. So as you can see, it lists some of the network interfaces, and it lists some of those virtual machine instances that it's attached to. So your security team and your security experts can identify that security risk with those network interfaces and obviously go and resolve them afterwards. And so now that we've gone over some of this as well, I want to go ahead and switch over to the demo to show you how this GraphRAG AI chatbot works. So let me stop sharing my screen real quick and switch over to our AI chatbot. So hopefully everyone can see this, but we've already been using this already for some responses. What I really want to quickly do is put in a very basic query asking it for a summary of the data sample set that we're using in PuppyGraph. So first I want to ask it, what are the statistics of this graph? And while the AI chatbot gets that response, I want to quickly navigate over to our PuppyGraph web UI portal. So from here, you can actually see the schema that we've uploaded for our data sample set here. And you can see the graph representation and structure and how it all works right here as well. You can even see the JSON file that we've uploaded here down here as well. But real quickly, I want to take a look at the nodes, our data points we have. We have private IPs, network interfaces, security groups, like we mentioned earlier in our presentation with our data sample set. And then we have these relationships between these data points, right? So network interface has this private IP or this public IP as well. And these are these relationships that our AI chatbot is going to be making contextual answers based on. So if we go back to our AI chatbot, you'll see that it's generated an output talking about all the nodes and all the relationships that are in this data sample set. And so this happens after that whole text-to-Cypher translation. It sends over to PuppyGraph. PuppyGraph gives those results back to our Bedrock agent, and then it's going to generate this response. And as you can see how many nodes there are, 1,275, how many relationships there are, 2,506 relationships. And you can see some of that data that we were looking at earlier through PuppyGraph's web UI portal. So users, internet gateways, VPCs, and also the relationships, right? So access records, contains, and the nodes that have those relationships as well are generated in this output. And so just to take another look at how our Text-to-Cypher functionality works is after our AI agent takes this Cypher translation, it sends over to here, where you can also use these queries through PuppyGraph's web UI portal. I'll go ahead and make sure I reload this PuppyGraph UI portal to make sure it's refreshed before I run some queries. I'll give that 1 second, and then I'll refresh. And that should be good now. And just an example of how this works, you can actually go into PuppyGraph's web UI portal, run these queries, and then you can actually see right here a visualization very quickly of the results from our data sample set. So you can see the security groups, and you can see the ingress rules that it has a relationship to. And so now what we want to do is ask our AI chatbot a natural language query version of this Cypher query. So I'll go ahead and paste in this same exact question, but this time in a way that a user would actually ask it in natural language. So what are some security groups that allow open access to SSH? And this is basically what we're asking through our Cypher query here on the web UI. We're looking for security groups that have a rule that allows public IP addresses, and also that have that port 22, which is a huge security risk since it's allowing these security groups to have access to public users. So as you can see some of those results here as well. So you can see the security groups that have access to SSH, and it talks about how each of these security groups have at least one ingress rule that allows open SSH access as well. And it gives some explanation to this as well in the output as well. Now let's go ahead and test out some more queries for AI chatbot. One thing your security team or expert might be interested in is knowing how many VM instances or seeing which VM instances have public IP addresses attached to it, since you don't want your VM instances open completely to the public internet. And so we can ask our AI chatbot this as well and wait for the response from the AI chatbot. And again, this natural language query is being translated into Cypher, being sent over to PuppyGraph. Those results are sent over to a Bedrock agent, and this is where that response is coming from. So based on our data, there are some VM instances that have public IP addresses, and it'll list the VM instances that have those public IP addresses, and it'll also show the actual IP address here as well. And it also talks about how it has network interfaces associated with both private IP addresses and public IP addresses as well. So it's taking that data, that data graph and PuppyGraph, and really making those context-aware answers and outputs for our user here. Last, we can give it one more query to see how this works. We can ask it where are some network interfaces that aren't protected by any security group at all. So we're looking for network interfaces that have no security groups attached to it, which is a huge security risk since these network interfaces need to have some type of protection from malicious actors and users on the internet. And so it analyzes that data, and it talks about how there's 94 interfaces that aren't protected by any security group, and it gives us some examples as well. So we have these network interfaces with their IDs, and it shows, it talks about how these don't have any security groups, and makes your security expert and team aware of this so you can resolve this immediately. And so that was a quick demo of our AI chatbot. I'm going to go ahead and hand it over to Jazz to conclude the presentation, but thanks for following along with this demo, and hopefully it was helpful.
Yeah, thank you very much for that wonderful presentation. Give me one moment to go back to sharing my screen. Yay. Okay, I hope everyone can see it. So as we did mention, I think you have access to the PuppyGraph cybersecurity demo if you want to take a look at the data that we used in this presentation. And if you want to play around with PuppyGraph, we do have a forever free Docker version available for download on our website because we know how much engineers love playing around with the products themselves. We also have the Apache Iceberg Digest ebook if you're interested in learning more about how Iceberg works and how graph analytics will work on that. And if you want to learn a bit more on how to set up the agents and everything, we also have the AWS Bedrock demo yeah, you can just scan the QR code and play around with it. So I think there were a bunch of questions in the Q&A that we were a bit too eager to answer, so I'll just reopen them so everyone can maybe gain more insights from it. So I think Ozan Ekin, I'm sorry if I butcher your name. I think you asked, what is the data loaded to PuppyGraph? Oh, sorry. You asked, what is the data loaded to PuppyGraph in this architecture? Is it a kind of projection from the original S3 table or just a schema? Waymo, would you like to take this question?
Uh, for this question, actually, we are doing a lazy fetch. So even you have a petabyte of data, but we won't preload any to the public graph. Only when a query is issued, and then we will do the optimization and know which part of the data need to be read, and then lazy fetch the data from data source.
Yeah, and then okay. So can we think of PuppyGraph as a GraphRAG engine for structured data? Yes, but actually I think we also support MongoDB, so we're like expanding slowly beyond just like your traditional relational databases as well. And then I think another question, do you have any benchmark numbers related to the accuracy of Cypher queries generated from the text? Waymo, would you like to take this one as well? I
Oh,
think.
this is really related to the quality of a prompt. And we have some customer, like for example, AMD in production, and their feedback is pretty good. And we also gave them a way to increase quality more and more. So like when some question cannot be answered, then we can just add the example into the prompt, and then time by time, the quality will be better and better.
Yeah. Oh, I think we also have another security company, Prevalent AI, that reached out to us for a similar use case. So I think it is being used in production as well. Yes. Okay. And then I think Harry, you asked, how does PuppyGraph scale when I have terabytes worth of data? So PuppyGraph is actually built for petabytes level scalability. You don't have to worry about that. We leverage parallel processing and vectorized evaluation technology. And because we are a distributed graph query engine, more machines equals to better performance for you guys. And then, um, Waymo, do you have anything you'd like to add on to that? Or
Yeah, I'll go ahead.
yeah, okay. And then I think Harry also asked, do we have a cluster implementation for PuppyGraph? Um, so Waymo, if you want to take over.
Yes, we are designed as a distributed system, and you can use Kubernetes to have a cluster deployment.
Mhm. And Ozan, don't worry. This whole Q&A session is about asking questions. Thank you for asking questions. So you're saying, what is the role of Amazon OpenSearch in this example? You store your data in S3 tables, your schemas in PuppyGraph, and you use PuppyGraph as your query engine. Are you also storing the embeddings in OpenSearch here? Syed, would you like to take this question?
Yeah, of course. So OpenSearch, we're using it as a knowledge base for your unstructured data. Like if you have security SOP documents or things like that that aren't really structured data, that's where that OpenSearch knowledge base is being used for to help you give additional context to those generated answers.
Mhm. Nice. And then, hi, Kevin. Thanks. Thanks for coming to the webinar. Okay. And then, Hari, is there an easier way to model the graph and puppy graph modeling for each and every table? Yeah. So I think right now it's an experimental feature, but we are trying to once you have your seed node, you can see what connects to it and slowly build the graph schema from there. Um, Waymo, do you have anything to add? Like what else is in the pipeline for us?
Yes, since usually our customer, some of them will try the auto tool at first, but before in production, definitely we need to double check if the graph schema is what they want. Since for the same, for example, for the same 100 tables, they can be different graph design. So the auto tool just give you a suggestion and the initial draft. But of course, you can modify the graph schema, and then later you can make sure you have the graph schema you want.
Yeah. Actually, yeah, another good thing about this is that you get to view the same data from multiple angles because it is just like a very flexible schema.json file that you're editing. And so, like, let's say if you have the same set of data, cybersecurity teams can use it, finance teams can use it for detecting customer churn and stuff. And so, in all honesty, yeah, it's really how you want to model your data. Okay. And then I think,
I saw in the chat also Jiten asked a question. Oh, we recently released the feature of multi-tenancy. This is a how tool from a lot of cybersecurity company, and they propose the feature request at the same time. So we just released it soon. I think 2 days ago. I think, yeah.
mhm. Oh, okay, interesting. Yeah, so I think while we really breezed through these what customers are using PuppyGraph today, um Waymo, would you like to give the list?
Cool, cool. Yeah, yeah, sure, definitely. Yeah.
Yeah, okay, so I think we do have quite a lot of cybersecurity use cases, cybersecurity companies that come to us just because of the nature of it, right? Because when you're trying to, like, attackers are trying to get into your system, so they'll take very complicated paths. Um,
Oh,
so I
and
think we have like, Yeah,
Also,
yeah, go ahead.
also Harry as the next question, which customer are using PuppyGraph today? Oh, we
Hmm.
have a lot of big logos like AMD, Palo Alto Network, and Coinbase, and Netscope, and recently we're from a different industry, but I think half of them are from industry cybersecurity companies, and more than half of top 20 cybersecurity companies are working with us. Yeah.
Hmm. Okay. And then are there any other questions? Okay. Well, just because I'm curious, so Syed, how was your experience building this entire demo for us? Like, was it smooth? What interesting things did you note when you were building it?
Yeah, very smooth. I mean, with PuppyGraph's like query engine, it's just you connect your data source to the query engine, and it's very smooth. You upload that schema JSON file, and from there you can start building, right? The AI chatbot. I mean, you connect your Lambda function, your Bedrock, which is pretty easy as well. So very smooth. It wasn't bad at all. Very fun actually, since PuppyGraph makes it easy for me to connect to my data source. So yeah, it was awesome building it with you guys, and really appreciate being able to do this.
That's great to hear. So how long exactly did you spend trying to make the demo?
For me, I mean, it took a while just for me because I'm not that smart, but
Hmm. Whoa, 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 don't
for a
say that.
regular
You did great.
yeah, but for a regular person
Mhm.
with the samples we have with the links we have on this presentation, it's pretty easy to get started making this, especially with strands
Oh.
that's been recently announced. You can make a Bedrock agent
Mhm.
and connect it to PuppyGraph to allow this functionality that we showed in today's demo. So
Yeah,
pretty
I think
easy, fast.
it's really cool how like AI has evolved over time to like, address the problems that we've been facing kind of stuff. Like you can't shove in too much context at once. And then so we started iterating and like slowly introducing the context so you lead to the right answer. And I think GraphRAG is just another step to bring us closer to actual like AI tools that work at an enterprise level. Yeah.
Absolutely, yeah, absolutely.
Hmm. And then okay. Um Yeah, and then okay,
As we get to a last call for questions, so we have 2 more minutes, 1 minute.
yeah. Any other questions? Let's start this wonderful architecture diagram. I think, yeah. Can agents connect to GraphRAG? Um,
So AI agents can use PuppyGraph to be enabled and be able to use GraphRAG. So agents can connect to
oh,
that PuppyGraph query engine and be able to give
mhm.
those GraphRAG answers, those context-aware answers that take advantage of PuppyGraph's data graph.
Yeah. We have an MCP server available if that's what you're asking. It should be available on our GitHub if you want to check that out. But yeah. Mhm. And then any cool. Okay. Yeah. Any last questions? If not, it's
Hey, no, someone
9:45.
raised their hand.
Oh,
Theo, if I, s- there you go. You can unmute, you can talk now.
oh, would you like to unmute?
Hi, Chang. I think
Um,
you raise hand and you are allowed to speak.
would you like to type in chat maybe? Hmm.
No worry, we can follow up with the translator.
Okay,
Oh,
let me
sorry,
just.
having issue with Zoom. Oh, okay, got it. Feel free to type
Okay.
your question.
Hmm. Can we build long-term LSTM using PuppyGraph? Waymo, would you like to take that question?
Yes, it's currently we even can something like convert your existing data as your AI memories and but for short term one, I think we have some writing to back to data lake things, and then you can store the context you just collected and write back into the data lake.
Oh, Sehir Chang asked, is there a link to the presentation? You'll be receiving a recording in your emails, and also, yes, we will be including link to the presentation if you want to review it again. Yeah. Okay. Any other questions? If not, I think, oh, brilliant. Okay. Oh, thank you. Such kind words. Okay. Yeah, okay. If not, I think we've gone over the session. Thank you so much for joining us today. I hope it was an enriching experience and I hope you guys had fun. Okay, then. Thank you so much for coming. I'll stop sharing my screen now. Have a great day.